For problem number 5C, again, we're using a function on an interval to try to find the absolute min and max values. And our process is going to be the same as we've done the previous two problems. We need to find the critical numbers that are within the interval, and then we're going to test the endpoints of the interval as well as those critical numbers that were within the interval. So our first step is to find the derivative. And we're doing the derivative f of theta. So theta is our variable here, so our derivative should just be 1 plus 2 sine theta, because the derivative of cosine is negative sine. So here's our derivative. So what we want to find is the critical numbers, but only the ones that are within this interval. So in this case, it's good they gave us an interval, because in general, when you set this equal to 0 to find the critical numbers, we would get an infinite number of answers because we have a trig function here. So if we move all of this over, we get that sine theta is equal to negative 1/2. So we need to find where this is true, but only in between negative pi and pi. So typically sine theta would be negative 1/2 at, if we were using our regular 0 to 2 pi interval, sine theta would be negative 1/2 when theta is equal to 7 pi over 6 and 11 pi over 6, and on and on and on. But these are both bigger than pi, and we can't use that. So in order to get something that's equal to these but lower, we need to just subtract 2 pi from each of them. So if we subtract 2 pi, we'd get negative 5 pi over 6 and negative pi over 6. So these two are the same angles as the ones above them. They're just on a different rotation of the unit circle, but these are within this interval, and that's what's important. So now both of those are within the interval. So we have 4 things to check for absolute min and max. We need these endpoints as well as these 2 critical numbers. So we're going to try f of negative pi. We're going to try f of negative 5 pi over 6, f of negative pi over 6, and f of pi. So we're trying to evaluate all of these, and we're going to see which ones give us the highest and lowest values. Now in this case, I'll let you know before we start doing this, these are going to be kind of hard to determine. This is not a likely test type of problem, because you would need a calculator to really deal with these. But let's start off here, f of negative pi. So remember, theta is just the angle, so we'd get negative pi minus 2 cosine of negative pi. So cosine of negative pi is the same thing as cosine of pi, which is negative 1. So this is negative pi plus 2, because we get minus 2 times negative 1. Negative 5 pi over 6. That's theta, so we just have that value. Now we're trying to find cosine of that value. So cosine is on the pi over 6 angles like that. It's going to be square root of 3 over 2. You need to think about what quadrant this is in. Negative 5 pi over 6 is in the 3rd quadrant. Cosine is negative there. So we get negative root 3 over 2. So we're going to get plus square root of 3 here. Again, because the 2's are going to cancel out, we have negatives on both. Okay, negative pi over 6. So now in this case, cosine is in the 4th quadrant, or sorry, this angle is in the 4th quadrant. Cosine is root 3 over 2. Cosine is positive in the 4th quadrant, so it's positive root 3 over 2. So we just get minus square root of 3. And finally, for f of pi, we get pi here, and we see that cosine of pi, just like the first one, is negative 1. So we get plus 2. So it's probably pretty obvious then that this one is the max, because is the only term that had two positive numbers, and pi is even larger than these other things. So that one's the max. Excuse me. And the min in this case, well, negative root 3 is about 1.7-ish, and these are all adding larger numbers here. So it's going to end up, since this one's two negatives and this is negative 1.7, that this one's going to be the min. Again, you wouldn't really have to do that on a test because those are numbers that are maybe not so obvious that one's lower than the other. But the idea of finding the absolute mins and max, same as these other few problems.
The Teaching Center, UF's Learning Resource Center.